On Tuesday's class, we did sine law for acute triangles, and we also talked about the primary trig ratios, so SOHCAHTOA, which should be a review from grade 10 math. And remember that you will be given these things on your data booklet, so you don't have to memorize them, but you do have to be very comfortable using them. So again, SOHCAHTOA should be review. If it's not review, or if you need a little bit of extra practice, you can talk to me, or go onto Google and Google trig ratio practice, and you're gonna just be overwhelmed by how much there is on there. And then we came down to sine law, which is that sine A over A equals sine B over B equals sine C over C. Or you can have the inverse, so A over sine A equals B over sine B equals C over sine C. And we name them by going opposite. So opposite angle A is line A, and B and C. And so when you use sine law, when you have an acute triangle, you look for either having two sides and an angle, or two angles and a side. And we talked about the scenarios for that. Where is it? Oh, right here. And for using sine law, you look for having side-side angle, so like side-side angle, or angle-side angle. Okay, and again, with the angle-side angle, this one's a little bit more flexible, because if you have two angles in a triangle, you can always find the third, because the interior angles in a triangle should add up to 180 degrees. And so we're going to move on to section 3.3 in your notes, and you got that notes package last class. Okay, so now we're going to work with cosine law, and again, we're still working with acute triangles. So when we work with a triangle and we want to know our original or our primary cosine ratio for a right triangle. So if we look at SOHCAHTOA, we're looking for this one, and cosine equals adjacent over hypotenuse. Now when you look at your right angle triangle, your hypotenuse is always the same. It's always going to be the longest side opposite the right angle. And then your adjacent depends on which angle you're looking at. So if I look here at this angle, then my adjacent would be here, and my opposite is here. And if I tell you, let's say this is a 3, 4, 5 triangle, so this is 3 and this is 5. To do my cosine ratio, so cos theta equals adjacent, so 3 over 5. That would be theta equals, now remember we talked about the opposite of cos is inverse cosine. So we do inverse cos of 3 over 5, and you'd get an angle of, just let me grab my calculator, of 53.1. Remember that you need to be in degree mode on your calculator. The inverse cosine or sine or tangent, you press the second or shift button. And then the other thing to remember, and this is something you should be able to call back from quite early in school, in high school at least, in a right triangle we can use the Pythagorean theorem. Okay, and that's to find sides. It's a squared plus b squared equals c squared. So if this is c, a, and b, if you have two sides of a right triangle, you can always find the third side. Always. Just make sure that your c squared or your hypotenuse is always by itself on one side. Then you might have to rearrange to get that. but just make sure that it's always by itself. And this is another one of those things to always keep in the back of your mind. When you have a right triangle and you have two sides, don't go to sine or cosine law, use Pythagorean theorem. It's the same idea with interior angles of a triangle always equal 180 degrees. When we start doing trigonometry, students tend to forget the really simple ideas that can still be applied, and Pythagorean theorem is such a good example of this. So now let's look at cosine law for an acute triangle. And the reason why we just talked about Pythagorean theorem is that cosine law is derived from this theorem. So using that theorem, they derived cosine law. So if we label our triangle A, B, C, and again label your sides A, B, C, then your cosine law can be written three different ways. So you can write it for each side. So no matter what side you need to find, you can write cosine law. And again, these are provided for you on your data booklet. So don't memorize it, but do be familiar with it so that it's not a surprise or a shock when you have to use it on a quiz or a test. So you can, if you're looking for side A, you'd be a squared equals b squared plus c squared minus 2ab, or 2bc, and these are all the sides, okay, not the angles. These are the sides, and then cos A, and here's your one angle. And same for B, so b squared equals a squared plus c squared minus 2ac cos B, again, all sides except for the B, the capital B, which is an angle. And then the same thing for c squared. So again, it just depends on which side you're looking for and which angle you have. So we use the cosine law when you have what we call side, side, side. So when you have all three sides and you're looking for an angle, or when you have side, side, and so you have side, angle, side, side, angle, side. So there's the angle we know. Okay, so when you have side, angle, side, or side, side, side. And in this case, it's important that the angle is in between the two sides. So if we have this triangle here, again, it's an acute triangle. So if I give you that this is 1.0 meters and this is 1.5 meters, we'll label our triangle ABC. ABC, and then we have 59 degrees up there. And we want to find the missing side, so this would be side A. And then I look at my rules again. I need side, 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 or side, angle, side. I have side, angle, side. So I can use cosine law. So we have side, angle, side. Can use cosine law. Okay, so we have angle A and we're looking for side A. So we're going to use a squared equals b squared plus c squared minus 2bc cos A. And if we look to see if we do have side B, we have side C, we have angle A. So that's perfect, that's exactly what we need. So then we just go through and fill out what we have. 1.0 squared plus 1.5 squared minus 2 times 1.0 and 1.5, and times cos 59. Okay, and we end up with 1 squared is 1 plus 2.25 minus 1.54511. So you have a squared. Remember that you still have your squared here, so make sure you pull that squared down. Equals 1.70489. And then if we square root both of them to get a by itself, a will equal 1.3057. If I look at my other two scenarios, I have one decimal on each of them, 1.0 and 1.5. So let's make this also one decimal, so a will equal 1.3 meters. So that is how you implement cosine law. It's just a matter of identifying which side you need and which version of the law to use. Okay, and then if you flip the page, we're going to find the missing angle for the triangle in the last example. So I just redrew out this triangle. It's a poor version of this one, but it's got all the same values. And then we're going to find a missing angle. So either angle B or angle C. And I'm going to find angle B because B comes after A. So if we want to find angle B, we're looking for the version of this formula here that has cos B in it. We want the capital B, and so this is the one we're going to use. And we have to check, do we have everything else? Do we have all three sides? We have side B, side A, and side C, and so we're okay because we only want one unknown in there. So let's find angle B. So we'll use B squared equals A squared plus C squared minus 2AC cos B. And remember that this is what we're looking for. So this is what we're going to have to isolate by itself. Okay, so let's fill in all our values and then get it by itself. So we have 1.0 squared equals 1.3 squared plus 1.5 squared minus 2, 1.3, 1.5. And then we're going to keep our cos B because we don't know what that is. And then what I'm going to do, I'll do this, 1.0, 1 squared equals 1. 1.3 squared is 1.69. We have 2.25 minus, and then 2 times 1.3 times 1.5 is 3.9. And again, cos B stays unknown. So let's move these over by subtracting them. So 1.0 minus 1.69, minus 2.25 equals negative 3.9 cos B. You end up with negative 2.94 equals negative 3.9 cos B. Right now we have 3.9 times cos B. To get cos B by itself, we divide by negative 3.9. We'll bring this over here. So we end up with 0.7538 equals cos B. Now we want B all by itself. The opposite of cosine is inverse cosine. So we have cosine inverse of 0.7538 equals B. And again, this is going to be angle B, so we're going to put this in degrees, and we'll end up with angle B equals 41 degrees. And then once you're at this point, so if we know that angle B is 41 degrees, we can easily find out angle C just because the interior angles in a triangle sum to 180 degrees, and so this will be 80 degrees. So always remember that when you're asked, say on a quiz or a test, find all the missing angles and sides. Don't do cosine law twice to find two missing angles. Find one missing angle and then use what you know about the interior sum to find the last one. Okay, so if you need to solve for an angle, you have two choices. You can plug in what you know and then solve for the missing angle, and this is what we did here. Or you can rearrange to isolate cosine. So at this point, what we could have done is, before we filled in any numbers, we could have put b squared minus a squared minus c squared divided by 2 negative 2ac equals cos b. Okay, and then you could have filled in the numbers. Either way is fine. So let's look at the second last example in here. We want to find angle B in the triangle below. So we're looking for angle B. And again, I'm going to look at what I have. I have 1, 2, 3 sides. I'm going to flip back here. Cosine law I can use when we have 3 sides or 2 sides and an angle. I have 3 sides. I can use cosine law. Okay, so we're looking for angle B. So we're going to find we're going to use the version that starts with b. B squared equals a squared plus c squared minus 2ac cos b. Okay, so this time instead of filling in my values, I'm going to isolate cos b right away just to show you an example of this. So I'm going to I need to move these two over, so I'm going to minus a squared and minus c squared, and they'll cancel out. So I'll have b squared minus a squared minus c squared equals negative 2ac cos b. Then to get cos b by itself, I'll divide by negative 2ac. Then I end up with b squared minus a squared minus c squared over negative 2ac, and I have cos b. Now I can fill in my values. So my b squared, again, if I look back at my triangle here, here's side b, side a, and side c. So I go 20 squared minus 19.5 squared minus 10 squared over negative 2 times 19.5 times 10 equals cos b. And I end up with negative 80.25 divided by negative 390 equals cos b. And so here I have 0.2058 equals cos b. To get b by itself, we take the inverse cosine of 0.2058 equals angle b. I'm just going to pull this up here. So angle b equals 78 degrees. Okay, so that's how you apply cosine law. With cosine law, like sine law, the hardest part is identifying what you have and identifying your sides corresponding with the angles. But then all you really have to do is fill in the law, which makes it nice because you are given the formula, so you really just have to plug things in and be careful with your calculations. Okay, so now we're going to sketch a triangle based on the equation w squared equals 15 squared plus 16 squared minus 2 times 15 times 16 times cos 75. Okay, so I'll draw my triangle. And then I look at this, I know that these three are sides, and this will be an angle. So I know that one of my sides is a w, so let's fill out w. We'll name our triangle w, x, y. And then this side will be w. This side will be y, and this side is x. Now I know, going way back to my beginning to what cosine law is, I know that whatever is on this side here corresponds with the angle. So here you have c squared equals, and you have cos c. B squared equals cos b. A squared equals cos a. So if I go back to my triangle here, I have w squared equals, so then I know that this is cos w. So here I can put 75 degrees, and that's w, and we don't know this one. That's what we were looking for. And then x, again, just to go in order, so x would be 15, y would be 16. So this will be 15, and here is 16. And there you go. That's how you draw a triangle based on cosine law. So for this section, there's some questions in the textbook here to work on. I'm going to have one more video on this week's lesson, so don't forget to watch that one too.